லெவன்த் சூரிய பிரகாஷ் மியூட்ல போடுங்க. மியூட்ல போடுப்பா.
Good morning, students. Today, we are going to discuss the chemistry chapter. It's the previous continuation. So, same topic we are going to discuss today also. Topic is solution. Okay, into that, we are going to discuss one of the colligative property. Okay, so one of the colligative property, depression in freezing point. Depression in freezing point. Okay, now before entering into what is depression in freezing point, okay, so first of all we want to know about what is freezing point. What is freezing point? Okay. So we know that what is freezing point. So it is a temperature at which, okay, so if you are taking that, it is a temperature okay, is a temperature, okay, at which the substance, okay, at which the substance is going to changes into liquid state to liquid state to solid state. Okay, but specifically, if you take the definition of the freezing point, generally we can say it is a temperature at which a substance changes into liquid state to solid state. It is going to be freeze. We are going to decrease the temperature. For this point and all, just you have to keep it in your mind. So, but in terms of definition, we are going to talk in terms of vapor pressure. Okay. So the freezing point, it is nothing but a temperature at which, okay, at which the vapor pressure of a liquid state, it is going to be equal to the vapor pressure of a solid state. Okay. So the vapor pressure, so that vapor pressure of liquid, okay, it is equal to the vapor pressure of solid. This vapor pressure of solid. Okay. Now, so if you take that, it is the vapor pressure of a solid and the vapor pressure of a liquid should be equal. So first of all, what is this vapor pressure? Okay. So this vapor pressure, I will give you the definition of a vapor pressure first. So what is vapor pressure? What is vapor pressure? So we know that vapor pressure is nothing but it is a measure of tendency of a material to change into its gaseous state. So it is a measure of tendency of a material, whatever may be. Material means it is a substance. Material changes into its gaseous state. Whatever may be the substance, okay, so that substance has to be converted into its gaseous state. This is term only named as vapor pressure. Okay. Now, particularly simply, if you give what is the definition for a freezing point means, we can say it is a temperature where we can note down where the change will be liquid to solid. So this is called a freezing point. Now, where that freezing point will occur means whenever the vapor pressure of a liquid. So if you are taking that, no, this is the vapor pressure of a liquid. So liquid has to water. It changes into its gaseous state. Okay. So the vapor pressure of a liquid should be equal to the vapor pressure of a solid. At that point only we will get the freezing point. Okay. Now I am going to discuss about freezing point and what is called a depression in freezing point. Depression is nothing but decreasing. Okay. So we'll go with what is freezing point and what is depression in freezing point. Okay. So first of all, we should remember freezing point means at a particular point of temperature, the vapor pressure of a liquid should be equal to the vapor pressure of a solid, then only freezing will occur. Okay. Now what is called vapor pressure? It is a measure of a tendency of a material or a substance changes from its its whatever may be the state. So that has to be converted into its gaseous state. Okay. So now if you take that, so what happened at the freezing point? Okay. So at the freezing point, so particular temperature. So you should remember at the freezing point means at a particular temperature. Okay. So what happened to the solid and the liquid? Okay. So if you are taking that, so if I am taking a liquid, okay. So liquid example, we can take water as an example. Okay, that liquid water, it exists equilibrium with the, okay, so existing equilibrium, this is called equilibrium, double-headed arrow mark. Okay, so liquid should be in equilibrium with the solid. So for example, solid, you can take a ice. Okay. So the freezing point, just we are going to consider an example, a liquid water is going to be changes into ice. Okay, the medium here we are going to discuss in terms of a conversion of a liquid to solid. Okay, so at the freezing point, now if you are taking that at freezing point, the liquid, okay, water is in equilibrium with the solid. What is the meaning of this? So at the freezing point, the liquid should be converted into solid. The liquid is going to convert it into solid. So the solid it is going to be converted into liquid because reaction. Okay, so that when we are introducing the equilibrium. So at this stage, we will get the conversion of liquid to solid or solid to liquid. So you should remember one point at the freezing point, the existence of a equilibrium between the two substances. So here freezing point means we have to consider the two substances, one is liquid and another one is a solid. Okay, and next, so how can we explain this depression in freezing point? Now I am going to explain by taking an example. So freeze, okay. So just I am taking water as an example. Water is going to freeze into ice. So we know that the freezing point of ice. The freezing point of ice. So we know it is generally 0 degrees Celsius. Okay. So freezing point of ice is 0 degree Celsius. So it is understood the liquid state of water is going to be converted into solid state named as ice. So this process will occur at a particular temperature of 0 degree Celsius. So that only we are given that freezing point of ice is generally 0 degree Celsius. Okay. So now, if you take that the freezing point of ice is 0 degree Celsius, so it is understood the liquid is going to be converted into solid. Okay. Now, during this process, we know that the solvent we are taking as a liquid water. Okay. Generally, that solvent it is going to be freezes and it is going to be converted into a solid form. So how this conversions? Okay, and what happened when you add one more solute into the solvent? What happened to the freezing point? I am going to explain in terms of a graph. Okay. So let us take a graph. I can plot a graph between this, okay, between the temperature and the pressure. Okay. So here I am going to consider entirely the pressure as 1 atmospheric pressure. Okay, 1 atmospheric pressure. So 1 atmospheric pressure. So just I am keeping the 1 atmospheric pressure line as like this. That is, this is I am going to consider this is a 1 atmospheric pressure. 1 atmospheric pressure. Okay. So we know that just we are taking a plot between the temperature and the pressure. Okay. Now, just what is freezing point? I am going to take a liquid. I am going to decrease the temperature. So I am going to freeze. What is the meaning of freezing? So you have to decrease the temperature. Okay. So whenever if you are decreasing the temperature, at one point the liquid is start to convert into solid. That is, the liquid water is going to convert into solid as ice. So it is understood the temperature of a substance it is going to be decreases. Okay. Now I am going to take a solvent. So we know that I am going to take a solvent as water. So solvent, water. Okay. So now we are taking a solvent, water. Okay. Now whenever decreasing of a temperature, okay. So decreasing of a temperature only freezing point will occur. So now I am going to take a solvent water. The temperature it is going on decreasing. So the decreasing of temperature I am going to indicate like this. This is a curve of a decreasing of a temperature. Okay. Now it is understood the water I am going to freeze. Okay. I am going to freeze. And this point, okay, at this point, it is going to be converted into solid. It is going to be what? Converted into solid. So, at almost this area, okay, this existing of a liquid form, okay, liquid form. At this point, it is going to be converted into solid form. So, it is understood. There exists an equilibrium between solid and liquid in this place. Okay. So this point only named as freezing point. Okay. So this is called a freezing point. This is freezing point. This is freezing point. And after that, okay, the curve, okay, just After that conversion of liquid, now only it started to converted to solid. So after that, it is going to be existed as a solid. So the curve is looking like this. Okay, so this point, this midpoint, just we are taking as a what point? It is a freezing point. Okay, so at this point only the liquid is start to convert it into solid. After that, it is going to be existing as a here what it is in the solid. So that only in your book they are given. This is area frozen solid, frozen solvent there, frozen solvent. It is nothing but if you are taking an example solvent liquid, it is going to be existing in the form of a ice. It's existing in the form of a ice. Okay, so now we know that just I am going to decrease the temperature. While I am decreasing the temperature, just I am getting one freezing point. After that, the substance, the liquid substance is entirely going to be converted into ice. So that only just the freezing point will be appeared. Okay. Now, where that freezing point, at what temperature the freezing point will be appeared? So the freezing point will be appeared only at 0 degree Celsius. Okay, 0 degree Celsius. Okay. So now I am going to relate the atmospheric pressure. Okay. So whenever this graph is showing like this, this point, midpoint, just for your reference, just you connect this curve into the atmospheric pressure. Okay. Then you can drop a line whenever this particular temperature. This is a particular temperature. Okay, this is named as a T naught F. T naught F. Okay, what is this T naught F? It is nothing but freezing point. Okay, freezing point of a solvent. Okay, what solvent they are taken? Water. So what is the freezing point of a solvent? 0 degree Celsius. So 0 degree Celsius, the freezing point of a solvent, because the liquid is going to be freezes at what temperature? 0 degree Celsius. Okay, now just remember, I am taking one liquid, the liquid as a solvent. Now that liquid I am going to freeze, I am going to reduce the temperature. Just on reducing the temperature, I reaches one point that is called the freezing point. Okay, that freezing point only there is a existence of a equilibrium between solid and the liquid. At that point only the liquid is going to be converted into solid. After that, it is existing what as it is in the solvent medium only. As it is in the solvent medium only. So that only I am just indicating that frozen solvent. Frozen solvent. It is nothing but ice. Okay. Now, just you keep it in this mind. I am taking only liquid. I am going to freeze. That is converted into solid. Okay. And next, what I am going to do? Okay. So, in that same experiment, I am going to add, okay, so we know that one solvent, okay, we know that one solvent. Into that solvent, I am going to add one solute, okay. So, generally, just I will give you that is a diagrammatic representation. If you are taking, consider this is your solvent area. Okay, solvent is generally we can consider water. Okay, water. Okay, now just we are it will be existing. How it is this? This is a solvent. Okay, so solvent existing in the vapor phase. Existing in the vapor phase. Okay, this is the solvent. Okay, existing in the vapor phase. So solvent existing in the vapor phase means all liquid form. So there is a free conversion of a vapor phase. Okay, it is understood. Now I am going to add. Okay, just I am going to add one volatile solute. I'm going to add one non-volatile solute. So it is non-volatile, so it's not being escaping as in terms of a vapor phase. Okay, non-volatile solute. Whenever if you add the non-volatile solute like this, it is understood. It is non-volatile solute. It decreases vapor pressure of a solvent. Okay, so it decrease vapor pressure of solvent whenever the added solute particle, okay, it tries to decrease the vapor pressure of a pure solvent. So it is understood. This is the concept. This concept only I am going to indicate in terms of a graph. Just I am taking one solvent, water. So water I am going to freeze. It is converted into liquid. This is one case. Now in the same condition water, if I am going to add a non-volatile solute, so you can consider this non-volatile solute example, we can consider urea, suppose for example, okay, urea, you are adding the urea. What happened to the freezing point? I am going to explain. Okay. So what happened to the freezing point? Okay. Now, in the similar way, this solvent, okay, so first it start to freeze ice, no problem. In the second condition, I am going to take a liquid solvent. Into that, I am going to add a non-volatile solute. So, what happened when you add a non-volatile solute into the solvent? Okay. So, the graph is shown like this. That is, so this graph is, we can take this is for a solvent. I will indicate this is for a solvent, pure solvent. Okay. Now the second graph, when I draw the graph for the addition of a solute to the solvent, the graph is showing like this. That is like this. So this is a graph for a solution. This is a graph for what? A solution. Because whenever if we add solute to the solvent, we are going to get what? Solution. What? Solution. So solvent plus solute, it gives solution. So this graph only for the solution. Now you can take this graph. Okay? So this graph shows that for a solution graph, it is going on decreasing. What is decreasing? The temperature is going on decreasing. But at one point, it tries to touch the graph of a solvent. Because at one point, it is going to be freeze. Okay. Now, that same, just for your just consideration, if you take this graph, it is going to be touches the atmospheric line, okay, atmospheric line, where it touches the temperature, okay. This temperature we can consider TF. Already we know what is called T naught F. T naught F is nothing but freezing point of a solvent. Now I am going to give what is TF. The TF is nothing but freezing point of a solution. Freezing point of solution. Okay. So from the graph, you can infer solvent, it is going to be freezes at a particular temperature 0 degree Celsius. So this is freezing point of a solvent. Okay, freezing point of a ice. Second graph, just I am taking a solution form. So for that solution also we are getting the temperature, but the temperature is less than that of a 0 degree, because the temperature is going on what? Decreasing. So below 0 degree Celsius only, the solution is going to be freeze. So the freezing point of a solution is going on decreasing. Why the freezing point of a solution is decreasing? Because of the addition of a non-volatile solute. Okay. So why this freezing point decreases means we know that whenever if you add a non-volatile solute, the concentration of a substance, the concentration of a solute is acting there. Okay. So it tries to decrease the vapor pressure of a solvent so that only the freezing point of the solution is decreasing. Okay. So if you take that T naught F, T naught F is what? T naught. Okay. If you take that T naught F is nothing but freezing point of a solvent. What is TF? Freezing point of a solution. Now, this point, okay, this between that two, okay, this temperature we can give del TF. What is this? Del TF. This between this point only we can name it as what? Del TF. Del TF. Okay. What is del TF? In between that two temperature. Okay. So here T naught F is freezing point of a solvent 0 degree Celsius. TF is freezing point of a solution that will be decreasing beyond the 0 degree Celsius. In between the two temperature, we name it as del TF. Okay. This del TF only. Just we are going to take it as this del TF. Okay. This is only called a depression in freezing point. This is only named as depression in freezing point. This is a measure. It will indicate how much temperature variation for the freezing point of a solvent and the freezing point of a solution. So del TF, that is nothing but it will be equal to, okay, it will be equal to T naught F. There is a difference. T naught F minus TF. This is a formula to find out the depression in freezing point. Okay. So how much the difference? Okay. How much the freezing point decrease? That will be indicated. Okay. That will be shown by the difference between T naught F minus TF. Here the T naught F is Sorry for the disturbance, students. Shall we continue now? Okay, we are in discussion about. So we are in discussion just how this temperature, that is the freezing point, is decreasing. So just I gave a mathematical expression. The depression in freezing point, that will be nothing but the difference between the freezing point of a solvent and the freezing point of the solution. Okay, this is the difference, del TF. Okay, now so this is only named as depression in freezing point. Okay, now if you take that this depression in freezing point, okay, del TF, this experimental research shows that the depression in freezing point is directly proportional to the, that is, the depression in freezing point, then TF, it is directly proportional to the molar concentration of the solute particle. That is, I'm going to indicate directly proportional to M. So this M is nothing but molar concentration of solute particle. Solute particles. Okay. So the concentration can be here. Just I'm going to consider the concentration term molarity. Okay. So whenever the experimental data proves that the depression in freezing point of a substance, it is directly proportional to the molar concentration of a solute particle, that is del TM, directly proportional to M. So in order to remove this proportionality sign, I'm going to indicate equal to Kf into M. Okay, Kf into M. What is this Kf? The Kf, it is nothing but molar freezing point, depression constant, or we can give it as, or the another name, cryoscopic constant. Okay, so Kf is nothing but molar freezing point, depression constant, or cryoscopic constant. So this depression in freezing point, we are going to relate in terms of a molar concentration by using one constant Kf. Okay, this expression also we should remember for the problem. Okay, next. So next we are going to see how this molar concentration, okay, will help us. Okay, the depression in freezing point will help us to find the molar mass of a substance. So the molar mass, okay, next we are going to find out the molar mass. Okay, and one more thing, if you take this del TF equal to Kf into M. If you substitute, okay, here M is what? Molar concentration of a solid particle. If you substitute M is 1, so for consideration, M is 1 molar concentration, then we will get a expression del TF is nothing but that time it is equal to Kf, cryoscopic constant, because this is also important. For 1 molar concentration, the depression in freezing point will be equal to the cryoscopic constant. Okay, that point also you should remember. Okay, next we are going to see. Okay, so determination of a molar mass. Determination of molar mass from depression in freezing point. Depression in freezing point. I'm going to find the molar mass. Okay, molar mass of solute. Okay, by taking consideration depression in freezing point. Okay, so we know already del TF. That is this del TF. It is nothing but KF into concentration. Okay, if I take here M as molality, because it is a concentration term. Okay, it is a molality. Just for consideration, here I am going to take a W weights. Okay, so WB, it is nothing but weight of solute. Weight of solute. Okay, you consider the weight of solute will be WB. So if you take WB, that is WB gram of a weight of a solute, I am going to dissolve in WA gram, that is the weight of a solvent. Weight of a solvent. You consider the WB is a weight of a solute, WA is a weight of a solvent. Okay, so you are taking a WB gram of a solute. I am going to dissolve in the WA gram of a solvent. Now I am going to find what is this molality. Okay, so we know that molality is a concentration term. Okay, you define that molality. So molality is nothing but, okay, molality is nothing but number of moles of solute is a ratio. Okay, number of moles of a solute, weight of solvent in grams. That must be conversion into thousand. So this is a formula for the molality. So what is molality? Number of moles of a solute into 1000 divided by weight of solvent in grams. Okay, we know that here M is a molality. Okay, now I'm going to find out what is M. So what is M? Number of moles of a solute with the weight of a solvent in grams, that must be multiplied with 1000. Okay, so here we have to substitute all the data. So what is number of moles of solute? Find out number of moles of solute. What is number of moles first? So number of moles formula, mass by molecular mass. Mass divided by molecular mass. So here the mass of the substance, if you take the mass of the substance, mass of the solute, I have considered what is the mass of a solute? WB. What is the mass of the solute? WB. Because that much weight only I have taken for a general consideration. So WB. What is the molecular mass of a solute? Just I am taking MB because M denotes the molecular mass. So MB, okay. So A for solvent, B for solute, okay. So what is the mass? WB. What is the molecular mass? MB. So now your number of moles is ready. Now you substitute into that molality formula. So molality, it is nothing but, molality is nothing but number of moles of solute. So what is number of moles of solute? WB divided by MB. Okay, and number of moles of solute is ready. Into 1000 you put as it is. Okay, into what is the weight of solvent? Here I have considered weight of solvent is nothing but WA, weight of solvent. It is a WA. This is only called a molality. So molality is what? WB into 1000 divided by MB into WA. WB is nothing but weight of solute. MB is nothing but molecular mass of a solute. WA, it is a weight of a solvent. Okay, now you are ready with the molality. Now just substitute this molality into the formula depression in freezing point. Okay, so here I'm going to substitute del TF. This is what? Depression in freezing point. This is nothing but KF into M. What is this M? Molality. Okay, now you substitute molality term into that formula. So just we can get the substitution del TF is nothing but KF into, what is this M molality? We can represent WB into 1000 divided by MB into WA. This is the formula of substitution of a M. Okay, but what we want to find out, just I am going to find out what is the molecular mass of a solute. Okay, what is the molecular mass of a solute? What is the molecular mass of a solute? It is nothing but MB. So I am going to find out what is MB. That is the molecular mass of a solute. So it is given by the formula KF into WB into 1000 divided by del TF into WA. So this is a formula. Okay, this formula you can utilize to find out the molecular mass of a solution. Molecular mass of a solution. So we know that already. Okay, so the depression in freezing point. So what is del TF? This del TF only. What is depression in freezing point? By using depression in freezing point value, we can find out the molecular mass of a solute. So that heading only I just given. So from the for the problems they are given the depression in freezing point value they are given. They are asked to find out what is the molecular mass of the solute. This formula you can utilize, but we should know that how to find out number of moles. So if you know that how to find out number of moles, it's very easy to find out the molecular mass of a solute. Okay, so just I gave a mathematical expression, and from that I have derived one formula, and that formula is relating the molecular mass of a solute with the depression in freezing point. Okay, so students, this class just we are in discussion about depression in freezing point. So don't confuse. Depression in freezing point is nothing but the freezing point value is going to be decrease. Okay, it is going to be decrease. Okay, so for that, just I am taking water. What is freezing point? What is called vapor pressure? So freezing point generally, just you have to keep it in your mind. Okay, so the vapor pressure of a liquid should be equal to the vapor pressure of a solid. Then only the substance that is going to be freeze. What is vapor pressure? It is a measure of tendency of a material changes to its gaseous state. Okay, now just I gave an explanation of taking a graph between the solvent and the solution. Solvent means pure water, just pure water. I'm going to take. I'm going to freeze so that one day I'm inverting the graph. Okay, from lower temperature. So the solvent water I'm going to freeze and just is converted into solid. Okay, so the graph is shown like that. That point we are taking as T0F. T0F is nothing but freezing point of a solvent. And next, same manner, I'm going to add one non-volatile solute into that solvent so that the freezing point of a solution is going on decreasing. So whenever the freezing point of a solution is going on decreasing, the difference between T naught F and TF only, given that what? Del TF, this is only called the depression in freezing point. The depression in freezing point, mathematical expression, T naught F minus TF. Okay. So this, by the experimental data, this depression in freezing point is directly proportional to the molar concentration of a solid particle. So directly proportional. In order to remove this directly proportional, just I am adding equal to sign, introducing the constant Kf. This is only called a cryoscopic constant. And by using of that, I am giving a one expression, what is called molecular mass of the solute. Okay. Students, now if you have any doubt, you can ask. First of all, can you hear me?
Ma'am.
Yes.
Yes,
Okay.
ma'am.
Yes, ma'am.
If you have any doubt, now you can ask.
No, ma'am.
No doubt, ma'am.
No doubt. So, can you understand what is called depression in freezing point?
Yes, ma'am.
Ma'am.
What is depression in freezing point?
Vapor pressure of liquid is equal to vapor pressure of solid.
Vapor pressure.
Pressure of solid.
I'm not asking what is freezing point. What is depression in freezing point? You can say very simple. Freezing point is going to be decreases. That is only called depression. Or you can give Miss del TF. This is only called a depression in freezing point. What
Freezing
is
point.
the formula?
T naught F minus TF.
T naught F minus TF.
TF.
Well, what is T naught F? What is T naught F?
Freezing point of solid.
Freezing point of solvent.
Point of a solvent.
Solvent. Okay. What is TF?
Freezing point of solution.
Solution.
So can you relate del TF with the molar concentration formula? Del TF is nothing but what? Kf into
KFM.
Good.
KFM.
KFM.
Okay, no doubt with that. Okay, good.
No, ma'am.
If you have any doubt, you can ask tomorrow. Tomorrow also I'm going to take class continuation of one more qualitative properties. Shall we close the class?
Yes, ma'am.
Yes, ma'am.
Thank you,
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
I'll pray.